know, my Mano Paul is my Twitter handle. If you do hear something that I say and you like to tweet about it, then it's at Mano Paul. Now, if you disagree with me in what I said, then it is a personal problem. It is your personal problem. No, if we need to debate, we shall debate. And so, you know, my primary identity is I'm a Christian, and I say that after 3 near-death calls. It is important. I got some sense knocked into my head, and my identity is that I'm a follower of Christ. And I say that because about 2 years ago, we founded an organization called Hackformers with the mission: teach security, teach Christ, teach security in Christ. And we have a few new chapters that are getting ready to be spun off with Carl in Indianapolis and other fellow brothers over there. And then we also have one that is in planning for Atlanta. It's not hot. Marcus Carey, tell him I said hi as well. So awesome. So thank you very much. So Hackformers, we do have a couple of cool T-shirts. I'm saying that because I just left them in the Hackers for Charity booth. And if you go there, you can see about 6 designs of T-shirts that we've got. What we're doing is really, the T-shirt sells for about $15 a piece, but the profits from those proceeds completely are given and donated to Hackers for Charity for Johnny Long and his mission. So go take time to go check that out. For those who have been asking about the T-shirts, I am ISC Square's Software Assurance Advisor. What basically that means is that I help the organization in making sure that the software and the things that we come up with regard to the credential itself, the CSSLP, the Secure Software Lifecycle Professional, is up to date and to the market, and it's something that is relevant. It's not just another certification. I've written a couple of books. The first book is the 7 Qualities of Highly Secure Software. You take a look at it. It's very anecdotal, and it's got a lot of illustrations that I think you would like. And then I've also written the ISC Square's official guide to the CSSLP certification in its 2nd edition. So if anybody is pursuing those certifications, then feel free to go take a look at those. For my day job, I work as the CEO of Secure Risk Solutions, a company that basically works on information security consulting, training, and products. But before I came into the world of security, I used to live in the Bimini Islands in the Bahamas. And why did I move to the US? That's a different story altogether. Having said that, though, in the Bahamas, I used to work as a shark researcher. So my friends actually know me as the Shark, and my hacker handle is the Shark. And then got some creds. Now, with regard to the talk itself, I want you to pay attention to this quote by John Erickson, who is the author of Hacking, the Art of Exploitation. He makes a very interesting statement, and it basically reads, an understanding of writing code helps those who exploit it, and an understanding of exploitation helps those who write code. And what basically he's trying to draw our attention to is that we live today in a world where, if I may be bold and daring enough to say, the era of the network hacker is dead. Now, what I mean by that is not that we have the network hackers are no longer, no longer prevalent in the industry itself, but that the attack is moving much more towards the applications. The software and the network on the cloud and other places is pretty much that line of demarcation is thinning or disappearing for the most part. So when I make that statement, I'm not saying that, hey, if you're a network, security administrator or a firewall guy, that, go look for another job. That's not what I'm saying, because that's how somebody took it when I said that in another conference. But what I'm saying is the network attacks have moved to the platform. Antivirus and other detection mechanisms have become stronger. And so now the applications are becoming the weakest link. And so it becomes important for us to bolster our application with the appropriate security controls so that we don't end up making them the weakest link, the Achilles heel in our organization. So what is this talk about? This talk is really about what you need to know as to how you write insecure code, right? I say that because when you know how to write insecure code, you would then know how to write secure code. How many of you have seen the movie Incredibles? What are you guys doing watching kids' movies? Right, we all have kids, so we end up watching them. How many of you the right question is, how many of you have seen Incredibles like 100 times, right? So, and still I'm going to have a show of hands. Now, in the movie Incredibles, the villain over there, Syndrome, makes a very interesting statement, and this is the statement he says. He says, when everybody is super, then no one is super, right? And that's kind of the parallel over here as to when you look at learning and knowing how insecure code looks like, then you actually can take into account and you can build in the controls to make sure that they're not insecure anymore. But then I also want to draw your attention and have a caveat said, and that is that making applications stronger is not about just writing secure code. There is a lot more than what meets the eye. Writing secure code is an important component, but realistically, it is something that has to go across the entire life cycle. And the life cycle is from the requirements phase, right? Whether you do this from a traditional development standpoint or you develop code in an agile methodologies, these phases are something that you have to do either at an accelerated pace in agile and extreme programming or in a traditional way where you have a proper project plan. And so when we have this in terms, and not that I'm saying that in agile you don't have a proper project plan, you still will follow it, but it's much more, a faster pace in which you do it. So in the requirements phase, we want to make sure that our protection needs are something that we elicit and we understand. And then in the threat model, in our design phase, we take into account the fact that if you don't master your threats, then your threats are going to master you, right? And so it's important in our design phase to ensure that the controls that we put into the code itself or into our software is something that will stand the test of time against hacker attacks. Then this talk is mostly around the development area, which is the code insecurity part. So I'll kind of after this, I'll allude to a framework that I would say that you could take back and use within your organization. It's not something that is published. It's just something that's kind of a mnemonic that you could actually take back and know that anytime I'm doing something related to code and the security aspects of that code, I could actually at least go and look at these basic steps, the basic elements in that framework itself. So and we'll focus fully, this talk will focus fully in that section. But then we also have the attestation part of it to ensure that the controls not only are existing, but they also are effective in their controls itself. So we want to make sure that from a testing standpoint, we validate the existence and the effectiveness of those controls. And then from an operation standpoint, how many of you have gone or have been part of either a discussion or have been subject to this fact that it worked well in the development environment, but it didn't work in the production environment? Okay, good. So I'm not living under a rock, right? So that's a common issue we see because we don't take into account a deployment or an operational focus when we take into account the development aspects. One of the things that is starting to catch ground, and it's actually becoming very prevalent, is something called DevOps. How many of you know what DevOps is, right? Looking at development from a design standpoint. And the DevOps, now if you don't do DevOps properly, and you don't take into account security in the DevOps process itself, it ends up becoming DevOps, right? So just keep in mind, and we need to take into account the operational aspects so that we deploy and we maintain code securely. And then one thing that is often left ignored is this fact that we always think about software as if it's got no end of life or the data that it handles. So if I was to ask you the question, how many of you have software that was written 3 years ago? Keep your hands up. 5 years ago. 7 years ago. 10. 15. God only knows when this was written. There's like no documentation. If we unplug it, we may get somebody to shut down, right? So unfortunately what happens is that software kind of has this perpetual life cycle, and then, or the data that it handles, or it handled, it's kind of just, it's a remnant, and we don't securely dispose it, and that becomes a weak link for us in our organization. So it's more than what meets the eye. We just want to make sure that we focus, although this talk is about code insecurity, we want to make sure that all the other processes throughout the life cycle is also addressed. So code insecurity, how do you write insecure code? All right. Now, if you were to take this framework that I was talking about, I used the word insecure, and I basically took all the different code samples that I've either analyzed or reviewed from a security standpoint and kind of categorized them into major buckets. All right. And it will fall into, if you look at this framework, it's going to fall into something. So the attacks that we see today that are prevalent is going to fall into one of these buckets or many or more. So the very first one is insecure, is code that is injectable code. And I'll kind of go over each one of this as to what that means. How does injectable code look? How does spoofing code look? The second one is non-repudiation, is non-existent in that code itself. It's spoofable. Errors and exceptions are not properly handled or they're mishandled. Cryptographically, the code is weak. You use unsafe or unused functions or routines are still being used within the code set. The code itself is reversible, and then the code runs with elevated privileges. So what is injectable code? How many of you have heard about SQL injection? or some form of injection. How many of you have seen SQL injection? How many of you know fully what SQL injection does, like what happens with SQL injection? So what's the primary reason why SQL injection is so successful even today? If you go and look at the newspapers, you're going to basically see some breach or something that has taken place. And most likely, if you kind of read through the, beyond the headlines, it's going to say it was an injection attack or it was some kind of a scripting attack. But essentially, what happens on an injection attack? Yes, sir. Excellent. So essentially, any user-supplied data, right, when not properly validated, ends up not being treated anymore as just the data itself, but it becomes an executable, right? So the input that we look at is not valid properly. And so let me do a quick demo here of SQL injection for those of you who are not familiar with it, or just to see what else we can do with SQL injection from its potency standpoint. So I have over here just a test site, and the site is something very simple where you're going to have an option to log in. And over here we're going to type in some kind of a username. Carl Sampson. What's your password, Carl? So we're going to try something. And now, what's that? 1, 2, 3, 4. That's okay. All right, now that was an invalid login. I don't know, he's not in that system or so, but somebody who's actually probing for SQL injection or so is going to do a very simple or 1 = 1 attack, which you probably are familiar with. And so if you want to see if this is an injectable code or this application is injectable, you would do an or 1 = 1, and you try to sign in. Now, when I was actually teaching this to my son, Ruben, who is over here, Ruben is 8 years old, and I'm really very proud as a dad today standing over here because I'm truly standing in his shadows. He was able to pop his shell and do key logging live in his talk earlier this afternoon, which I'm not doing. Right? And so I was talking to him about SQL injection, and it went 1 = 1 = dash dash, and he basically goes, why don't you try 2 + 2 = 4 dash dash, right? And it does work. So now I hadn't thought about it. I should have thought about it. We should have known about it. But it's simple how children think differently, but yet they can teach us a lot. And so if you missed the talk, highly recommend, catch it when it's out on the videos. So 1 = 1 dash dash. There was a bypass. Essentially, as this gentleman over here has mentioned, that input that was sent was not validated properly, and so it basically became part of an executable context. And so it in the backend ended up becoming a true command to the backend interpreter, the SQL interpreter in this case, and it bypassed me. Now, what can I do with just SQL injection? Now, you didn't come to see just basically an or 1 = 1 bypass. So something that you could do then is, if I want to now try to find out about the database itself, try to pass in an incorrect syntax, saying having 1 = 1, and you see on the screen something that is verbose, and what do you see over there? We'll see. Yes. There's a lot of information that is not over here, that should not be actually disclosed, but if errors are not handled properly, you actually end up seeing something about the database, and what's the column name in the database? You have a users table, and then you actually have a user ID column. But what's interesting about the error is that it actually tells me you're getting this error because you did not see a group by, you did not use a group by. So all I would need to then do is go back and do a group by user ID and try signing in, and now it tells me what? The user login is. So this is a good tool for organizations when you don't have a proper backup routine and you don't know how your database schema is. You can use this to actually find out how the data is. Right, so here I would go and then basically say, by user login, I'm going to log in, and now user ID and user login, and then it tells me that the user password is not there. So I can start enumerating through the database itself and then get this. But for purposes of time, I'm not going to go through all of it. I'm going to just tell you it's got user ID, user login, user password, username, and then a date created column. And so when I actually go back and run this, what happens is after I've gone through all of the columns and enumerated it, it actually does not error out, and that to me is an indicator that that syntax was valid and that there was nothing else to be grouped by. And so I basically enumerated through my entire users table and known every column name that's there in that user table. All right. Now, having done this, what's the big deal about it, right? It's injectable, yes, I know, but what else can I do with that injectable code base itself? So at this point, it kind of gets interesting because rather than actually doing just an injection attack to find out the username, I could then go and try to do a sum of select minimum user login from users where username, user login is greater than, and let's say just the first word is at, somebody with an A, starting with an A. Okay? So now nothing happened. Why? Because the syntax is valid and it actually is doing a syntax check against the backend database. But I want to see some information, so I would actually force the system to error by doing a union clause. Unless I'm missing something there. All queries combined. Oh, okay. All right. That is, I didn't give the correct number of columns. We had 5 columns, so select 4 more blanks. And at this point, it actually comes back now with the data from the backend system saying that you're trying to do a minimum, a mathematical operation from that user's table, right? And so Calvin Hobbs is the username. The next thing I would really go about doing is from that point, I would take Calvin Hobbs and then I'll see where that username, user's password is. So if I go in over here and I will say, now give me the user password where the username for user login is and you get that user's password. So I can now go with Calvin Hobbs and that password. Data is being spit out on the screen. So injectable code can also lead to disclosure attacks. And this is how they actually steal your information. Now, as an attacker, I'm not going to be basically going through each column and then say, now where the username is greater than Calvin Hobbs. Rather, what I would do is I would do something like this, where I would write a script. And I'm over here declaring just a temporary holding variable, setting the accounts and passwords to be selecting from the username, user login, and user password from the users table, where the user login is greater than the one that just got set, and I'm going to read that entire thing into a temporary user table. So if I was to go do this, what would happen is, show you here at this point, run this, and I sign in. It seems like nothing happened, right? Now, a script kiddie at this point would just go away because they don't know really what they wrote or what did the system really work. But a determined attacker is going to go one step further and they're going to try to sign in again. And what does it tell? I cannot create the temporary user table because that was already created in the previous execution of the script, which means my accounts and passwords are there in that script or in that temporary user table from before. So at this point, essentially, I would go and read off that table where I would say union select accounts and passwords from the temporary user table. And then over here, you actually have an enumeration of 3 users, Calvin Hobbs, his password, John Doe, his password, G.I. Jane, her password, and so on and so forth. So at this point, I could go through, if you had 1,000 records, everything in that one line of script, essentially I could steal that information because that code itself is injectable and it's taking whatever user supplied data I pass in, and it's actually having an execution context tied to it. Now, of course, there's one step left. Who can tell me what that is? Should be done at this point as an attacker. Hide your tracks, right? So drop table, temp, user table. Is that what I called it? Temp user table. And you sign in, nothing really happened, but really did nothing happen. You sign in again and it says, I cannot drop that table because it actually fired, ran the script earlier, and at this point, the thing that beautifully tells me is nothing happened, or I cannot drop this table, and that you do not have permissions, right? By this time, Elvis has left the building kind of things. So injectable code, what does it really get us? It kind of makes us have disclosure. Input data is essentially treated as a command, and this can lead to, whenever the code itself is dynamically building that query that gets executed, the code is basically injectable. And so insecure code that is injectable has these characteristics because input validation, and it takes accept pretty much anything to the backend system, and input validation is pretty much non-existent. Right? Non-repudiation. This is the other code that is not existent. And what this basically means is the authenticity of the code itself I cannot verify. Right? So if a certificate has been spoofed and that certificate has been the one that's used to sign that code when you're publishing software, in that case, then you can't really verify. But what happens really, whenever you see a pop-up and it says, do you accept the certificate? What do most people do? They click it, right? So do they really go forth and verify it? Some probably do, but even after they verify, they probably would click it to run it if they want that functionality. Basically giving runtime permissions for that entire code set to be able to execute on your system itself, right? But from a developer standpoint, a code that is non-existent, a code wherein non-repudiation is non-existent is one where I can't track back the changes of that application's functionality to the code itself. So what that means is I'm not tracking who did what, when, and where, right? So some things that we need to look at when we actually look at, I'll kind of get into the controls part when I go to the second part of this talk, and that is how does good code look that has addressed this aspect of non-repudiation, or that, the deniability itself of the code. The third is code that can be spoofable, right? Now, what is spoofable code? This often we see in many systems that are in production, unfortunately. And what that means is, for some reason, the developer team or so have written some code with an impersonation context switch, right? Which then becomes the backdoor for the attacker. How many of you have seen where you can actually change the principal identity of your code base that it's executing with by just sending in some flag or so that you can support it to, in production? Anybody has seen that issue, right? So what happens in that situation is the developer writes it, and it's essentially a maintenance hook. It's non-innocuous. It's innocuous in nature until, somebody who's malicious in intent ends up using it for the bad purposes. And so spoofable code is one where the code itself allows the ability for someone to spoof another person's identity. And this often is represented to us by the credentials that are weak, something that is cached, or something that is hard-coded. And then when we talk about session management itself, the session identifier itself is not generated or maintained in a proper way so that an attacker can fix a session. So in the case of .NET, any .NET programmers over here? A few, right? How many Java programmers? You don't want to claim with yourself. I'm sorry about the whole Java 0-day issues, but no. So we have a good, and then you have Python and Ruby, and yeah, good. I could tell from the color of your hair that you were not the non-conventional one. That is awesome. So from the standpoint of the sessions itself not being maintained, in .NET, in the framework itself, there's an option for you to set the flag for cookieless authentication. You know what it does, the framework by default? If you set that flag for cookieless authentication, it creates the session ID, and then it actually does what is called a URL munge. It passes it in the URL, and then it retains that session ID in the backend server so that there's nothing on the client maintained as a cookie to have those transactions. So what happens is I could do what's called a fix and foul attack or a session fixation attack, which basically means that you create a session on that server, or an attacker would actually come and create a session on the server. Then I would do a clickjacking attack to make you use my session in terms of write over on my session, and then you come and log in, do your thing, and you log out. The session is still active on the backend system, and I'd be able to get access to your information and your data. Right? It's a classic, fantastic attack. If you haven't played with it, go and look up session fixation attack in .NET, and there are some samples that you can go try. Okay. But again, I should say with a disclaimer, you tell children don't run with scissors, what do? They run with scissors if you give them a scissor, right? So be diligent, make sure you get the appropriate permissions and all that if you're going to try something, especially if you're doing it against your production system. All right, we actually saw this errors. This is another code characteristic that is very commonly seen, where the error itself is very verbose in nature. It's not redirected. It's not unhandled. Many times it's just thrown and bubbled up to the client. How many of you have seen the cyclical loop of throw new exception, throw new exception, throw new exception, hoping that someone in the front end is going to handle it, And now if you have a diverse team where multiple developers from across the board are developing it, at that point what happens? Who's handling the code? The user, right? Or if in the case if it's an attacker, they're actually getting access to very valuable information that they ought not to. So be very careful when you do your code review with regards to errors not being properly handled. And in many systems, unfortunately, they end up differing to a fail open as opposed to a fail closed. So you try a couple of times. If it doesn't, it gives you kind of an access still to that restricted system itself with either guest or other privileges. So be very careful when you do that. Cryptographically weak code. This is the C in that insecure framework. And what that basically means is, how many of you have written your own algorithms? You've tried sometimes, right? So most of us, we've tried sometimes the ROT13s to the Caesar ciphers to all that is so, so easily broken. But developers are creative. If you give them a chance, then developers are going to write their own algorithm, right? That becomes a problem because that ends up becoming the weak link. When we have cryptographically secured applications or secured data that are being secured through those algorithms itself. And then the other big problem is the key itself is not managed carefully. So from the generation of the key, right? How do you generate the key? Is there pseudo-randomness? Is there entropy in it, right? So the strength of the key, the size of the key, all that becomes important. And if we don't take into account proper controls in place, which we'll see later, then the key becomes your weakest link. So it's very similar to the analogy of locking and bolting your doors, making sure you have every control in your house, and then leaving the key under your mat, right? So the key becomes the weak link in any cryptographically weak code, as well as the algorithm itself. Another thing to keep in mind, though, and we've seen this, just because you have a higher strength key, like a bit-sized key, is 256 or so, it doesn't necessarily mean that if you use it with an algorithm, it is automatically giving you that advanced or higher level of protection of that data itself from being decrypted. And I say that because there's a combination factor of the key size along with the algorithm strength. So that if the algorithm, let's say it's an RC4 algorithm with a lower base key strength, will probably be more stronger than an AES with a higher base key strength. So it's important for you to take into account both the key size and the algorithm strength while you choose your design for your cryptography within your applications itself. Now, this other thing is, using unused or unsafe functions or banned API. In some languages, we call them deprecated API. We've seen this as well. In fact, what is interesting is we thought that this was going away with the movement of software development, technologies from the older C, C++ to more of the .NET, the managed code, the Java side. And then it kind of came back full circle when we started moving into the cloud. Because what is happening is now the API is not necessarily just a code API in your language, but it's now an API that is insecure, or the interface itself is insecure when you do it across the cloud, right? And who maintains that API? Who's got access to that API functionality? That becomes important. So if you're into cloud development or you do cloud development, take into account, because in the Cloud 9, how many of you have read the notorious 9 of the cloud? If not, if you do cloud development, I'd highly recommend that you go read it, because it's like the 9 top attacks or the 9 top threats in a cloud environment that you need to know about. And one of it, I think it's number 2 or so, is insecure interfaces and APIs, right? And then I kind of talk about this. How do developers usually code? You know about this Control X, Control C, Control A, Control X, Control C, right? Code reuse, right? So often what happens is, we see that they would take a code base, or they'll take something from one code base and they would port it into their applications without fully understanding its context, and that ends up becoming a weak link from the standpoint of insecure, banned APIs and things that we inherit into our code. And then Easter eggs, right? What's Easter egg? What is an Easter egg? Oh, everybody stand up and give me 20. There's no trick question over here. It's the developer's fingerprint in the code, right? They kind of say, if you have these combination of keys that you type, then something like this is going to come up, or you're going to have all these. There's some really cool Easter eggs from the Microsoft Flight Simulator in Excel 97, right? Now, Microsoft as a company had to take a policy saying that if we find Easter eggs in the code that is developed by our employees, then they could have serious repercussions. like loss of their bonus, to even serious termination, because that is an Easter egg. The way you would tell an Easter egg is an Easter egg is you would not find it in your requirements traceability matrix, right? So you can't really test it. No one has tested it, but then somebody knows about it, and that could become, it doesn't go through a proper threat model, and that becomes a weak link itself. And then code that is reversible. Now, just because code is compiled doesn't mean it is secure, right? It could be compiled and then it could get ready to go into deployment. But at that point, if it's not properly, if it's not obfuscated, which basically is just a deterrent to reversing, right? And if it has what's called textual and symbolic information, or it doesn't actually have checks for debugger present. So I'm going to actually do a quick demo of this I can do because this is no longer vulnerable. And this is actually on the Skype application when it was a standalone application. I go to that. So what happened is once while I had for some work in my laptop, I had to actually have some debuggers installed. And in the early days, we had this debugger called Softice. Anybody know about it? It's a kernel level debugger, so you basically can hold the operating system and do some forensic research, and you can do malware analysis and things like that. So I had it on my system, and I had gone out to Portugal for a business trip. When I was there, I tried to call back home using Skype, and as soon as I typed and I turned on Skype and I opened it, I got this message. Skype is not compatible with debuggers like Softice. So I wrote to Skype, and then Skype basically wrote back to me, and they said at that point it was about a 24 to 48 hour response. They basically said that, you should uninstall Softice. Now, for those who have actually done any kernel level debugging, having a debugger on it, uninstall Softice is not like going and clicking, a button to say uninstall, because it has hooked itself into the kernel code itself. At that point, it's using interrupts to be able to access kernel level functionality. So you can't really uninstall Softice. But then to look at this, one of the things I ended up having to do was to see what is really happening. Why is it throwing this pop-up? So you have the poor man's debugger, which is Ollie Debug, if you don't have IDA Pro, right? Then open up the executable. And then once it opens up, do an analysis of it. Doing an analysis. As soon as it completes its analysis, I kind of got lucky because as it was going through that analysis, it paused at that point where that pop-up was getting to be thrown. And if you notice carefully over here, it gives me the same error message. Skype is not compatible with debuggers like Softice, right? So you go through and you see that this whole code base over here, it's a message box, okay, it's an application model, which means I have to click on it. It's not going to let me click on anything else. It's got a title that's Skype. But then what was interesting is just about that, there is a code which checks something. And what it really is checking is this. It's checking to see if it's jump if it is not equal to 0, right, at that address space. So, now I'll tell you why I'm showing you this in terms of textual and symbolic information. You could basically fill it with a no-ops sled, or you could go and say anti of that check, which is instead of jump not equal to 0, or I'm going to do a jump equal to and assemble this. Copy by selecting all. I'm going to copy this selection to an executable. I'll basically reassemble that code, and I close it. It's going to tell me you modified this code, so are you okay with, making changes to it? If you say no, you lose changes. If you say yes, then it'll ask you to save it with a file name. And then on the desktop, we'll call it Skype patched and save it. Now when I go back here and I do a Skype patched, it completely bypassed that check, right? And I was able to call back to my home, to my family that I was missing dearly. Now, the reason I say that is this. Now, it's not that we were hacking in the sky, but the information that was in there with regard to that textual information, soft eyes and debuggers like soft eyes that is being put in there is the one that somebody could use against your system and be able to see what logic needs to be switched over. Now, this was a very, very simple bypass. It should have never been this. What really should have been there is they should be checking at runtime, is debugger present, and making sure that all of that symbolic information and the textual information was not that easily decryptable, right? And that you could go with, that somebody could bypass or reverse that software itself. So at this point, let's go back to our presentation, and that's symbolic of some of the reversible code itself. The last one over here is elevated in privilege, and what that is that the code itself requires administrative privileges to run, and it runs operations without proper authorization itself. Now, this is basically in the case when you don't have proper configuration management controls, where the code runs properly in one lightly controlled environment, but when you move it to a more tightly controlled environment, then it doesn't run. And often what happens by elevating its privileges, it has access to the system functions or the system devices and the system resources, and it ends up actually executing, but then it's running with an elevated privilege, and there's a problem with that. Or it's doing privileged operations, like changing the password or changing your account information without doing what's called a complete mediation check to re-authenticate and make sure that you are really the one who's claiming, so that, claiming that change or requesting that change itself. So now that we know how insecure code looks like, what do we do to actually go and do code insecurity, which is how do we write secure code? And this is simple because we're basically going to do an antithesis of the previous one. So when we look at injectable code, what you really see is that input validation needs to be in place. Now, where do you validate the input? Do you validate on the client side, on the server side, or is there like a always? Really? There's no valid example or reason to do it on the client side? What? I'm with you. So client side for performance reasons, so that you offload the server, handling. If it is something as simple as don't let it go to the server, but always do it back again on the server side, even after you do it on the client side, because a proxy or an interceptor can easily bypass, all the client side validation, and you could still send information back to the backend system. Now, I say that because we had an application we were reviewing, and my friend was the one actually reviewing it. This was a government contract application. It was a pretty sensitive application, but the moment he typed his username and his password, in a fraction of a second, it gave a pop-up saying that your password is invalid. And he, being in the security field, is like, it could not have taken that much time for the server to respond. Like, it happened too fast. So he typed it, and he did the whole view source thing, and he saw that the password was hard-coded in the client-side script, saying that if the password is this, right, then show this message box as an alert, JavaScript alert. Now, he wrote to the company. I kid you not, within like about a day, he thought since it's a government application, it's probably not, it's going to take forever to come back, if at all anything comes back. But now, he gets a response back within a day, and they said it's been fixed. So he goes back to check it, and he changes the password, he types another password, immediate response. They did the fix, but they changed the password on the client-side script. Right? So just so, always back-end server, making sure that validation is taking place on the back-end, and it's not. So we still have those applications that are lingering out there. We shouldn't be coding applications that are of that sort. Now, parameterization of queries basically takes that user-supplied input and makes sure that that is no longer just treated as an executable. It is treated as a parameter or as a literal. Now, having said that, you also need to make sure, we actually were looking at a code base where we went and told they had in this application, there was about 600, 700 stored procedures. So we said all of these are taking some kind of a user input, or majority of them are taking, so you need to go and parameterize your queries. Within like a week, the development team came back saying we fixed it all. I'm like, dude, that's like super fast programming you guys have. So essentially what they did was they'd taken the 600, 700 stored procedures, written one stored procedure, and the parameter that it was taking was the procedures that was building. It was basically passing in the inputs, and then it was run, execute, query, and it was basically querying. So it really didn't do anything by parameterization. So make sure that in the code itself it's properly done, and that you truly take parameters and not a query as a parameter. I talked about defense against non-repudiation. Code citing is one thing that can help you, making sure that your certificates sign the code before you publish it. But also, from a developer standpoint, the W's that you need to know, right? The 5 W's. Who is the identity, did what, the action, right? Whatever the action was, where, the objects or the resources, when, the timestamp. And then in terms of the why really you can't code in, but if you have the first 4, who did what, when, and where, you kind of can come back as an incident response to any breach or any security incident, and you can figure out why something happened. So make sure you have what's called these audit fields built into your application itself. Defense against spoofing, right? What are the things that I could do? Making sure that you don't have impersonation context in code. Do not hard code any credentials or cache credentials. From a session management standpoint, making sure that you have end-to-end session management, and it's not just something that is, a predictable session or a non-guess, or it's a guessable session identifier itself. So from the generation of the session to maintenance of the session, and as to where it is being stored, the IDs, making sure that that is protected is important. From a defense against errors, the first and the best defense is let your words be few, right? Instead of saying username and password does not match, just saying login invalid is far more sufficient. It still communicates the same information back to the user, right? And then if they continue to keep on making errors, which you have to keep supporting, and they're uneducatable, then basically you have to tell them that this error code means the problem is between the keyboard and the seat. So making sure that you have laconic error messages, catching all exception, don't leave any exception, encapsulating internal. Now, there is, from software design standpoint, one of the things that you could do is essentially not spit the error back, but if you have the resources to be able to handle and support that error that's being referenced, then reference map that error to something that is in your support system, and all you need to do then is to give the error ID, right? And that's something that they can call in, or they can have another out-of-band process to be able to check, especially if it's a sensitive system. Now, all this will come with a cost, but it's important depending on how your software is, how sensitive, how valuable it is to your organization, to the amount of security that you need to build in. And then redirecting your errors to a unified error handling page becomes important as well. Avoid custom encryption algorithms. Don't hard code your credentials in code for making sure that your software or your code itself is cryptographically strong. Being cryptographically agile. What this basically means is that how many of you had to deal with changing either crypto keys or crypto algorithm in your code base? Like, you've been in the company so long that some of you, right? What happens is people hard code the algorithm and the key in the code. And so MD5, which was a couple of years ago touted as a strong hashing algorithm, right? About a decade ago, now is no longer accepted as a valid standard, and you go with something like SHA-256 or SHA-512, and that's something that you need to code. Now, if you have to go back and change in every code base, it becomes a very onerous process, and it becomes very difficult. In fact, it could also lead to leaving some things unfixed, and that could become the weak link in your organization. Cryptographically agile is like using cryptographically new generation, like CNG APIs that are there today to be able to configure your algorithms so that you swap them almost like a hot swap, and that you do kind of a decrypt with the old code, decrypting the old with the new change. And so it's it's more of a design issue where you have one place where you can configure the algorithms so you're cryptographically agile as new attacks or as weaknesses in algorithms are being found. It is extremely crucial for us to be able to manage the key, and that means when you start the generation of the key, taking appropriate pseudo-randomness. The problem with pseudo-randomness is what? The word pseudo, right? So it's almost, there's no like non-deterministic algorithm that is truly random in our computing world, but we have to deal with it, at least, but adding in the amount of entropy that is necessary for the size of the key, the strength of the algorithm itself is important, and using standard and proven algorithms. Avoid any hard-coded keys, be cryptographically agile as well. So from the generation of the key to the storage of the key, where do you store it? Making sure that it's in configuration or in sets that are out of band, exchange of the key also an out of band mechanism, or if it's public key, then through the appropriate digital certificate mechanisms, the PKI that should be in place. Those are the ways that you would store it. And then one of the most important aspects of key management is the key rotation and the key disposal. What happens if you actually rotate your key and you didn't archive that old key, but you had data that was encrypted with the previous key? You basically created yourself what I call a CDOSA attack, a self-inflicted denial of service attack, right? So make sure that you have the proper processes in place so that the code itself is cryptographically strong. And then from an unsecure, unsafe APIs or functions, what are some of the things? Remove any or replace the banned APIs. Delete any unused functions. Now, in some systems, you have the option to actually uncheck, but leave the system in. It's still there, the function is there, but you just don't have it enabled, right? There's a problem with that because an attacker who finds out that that application or that software has got some kind of a remnant of a privileged code operation, right, can turn that on, and they probably will do that. Like, for example, the XP command shell prompt, right, the extended procedure in SQL Server installs that was turned on by default in the earlier versions. What was the necessity for that? So that a hacker can essentially do a port scan on your network using the most expensive scanner, which is SQL Server. Right? So, right? There was no need for that, right? So it's important to make sure that you don't have, just delete, do not, and just leave it in a disabled state. Delete any dangling code as well, right? Dangling code is commented code. That has sensitive information. One of the things that we see in code reviews is this. They will have the connection string of the test database that is commented out as it is being ported into production because it's being changed into production. But then somebody who wants to get into your organization can get in through that test database. And in many cases, you have test data, production data in test environments. Anybody have that issue? Everybody, right? So it could still lead to sensitive information. And then do an Easter egg hunt, right? It's important. How many of you do an Easter egg hunt in your code reviews? Yeah? How many of you do a code review? Right? So make sure that you have that as part of it because that's never going to be part of the functionality itself. Defense against reversing itself is obfuscation, kind of making it difficult for the readability of the code, signing of the code. Application hardening, which is basically taking out the symbolic and textual information. There are things called opaque predicates that you could actually build in, and then making sure that your isDebug or present API checks are not something that can be easily bypassed or spoofed, or circumvented. Defenses against elevated privileges, check authorization before actually allowing any privileged operations. Always making sure that you run with least privilege, right? Non-admin accounts, and then making sure that you have an environment to test. Now, this is actually becoming easier. In the olden days, it was much more difficult to do simulated testing because we had to provision the hardware, get the time set up to configure the hardware to match production. But today, it's like spinning off an instance in the cloud. It's very simple, very quick, and so you can actually leverage the cloud to your benefits to be able to bring up your test instances that mirror your production and do the appropriate testing that you need to do from a simulation and a regression standpoint. So in conclusion, by knowing how code insecurity can impact us, we're really looking at how we can code in the security, and then going forward, it's your choice, an option that you have, right? To choose either you're going to go code insecurely or you're going to code in security, and then go forth and may the source be with you. I have my contact information over here. If you like this presentation or you did not like this presentation, you need other on-code presentation for your companies, you have any awareness training, consulting needs, then feel free to shoot me a note. I'm on LinkedIn. With all of the breaches happening on LinkedIn and all those things, I'm wondering if I should just say on LinkedIn, right? But I'm on LinkedIn. Yeah, go ahead. You can shoot me a note on LinkedIn. On Facebook, the only thing is I use Facebook mostly for like friends. Sometimes I say things or do goofy stuff, and if you are, if you get offended by it, then if it's my family and friends, they often know that I'm okay, but so I use it mostly for personal reasons. But on Twitter, I exclusively use Twitter for security updates and security stuff. So if you follow me on Twitter, then I'll follow you as well. If I'll just follow you. So if you guys are cool. So, and then have a great day. You can contact me. Actually, have a great evening. And then contact me with any of those emails. Then thank you, and finally, code in securely. So see, there's no throw exceptions. It's all about making sure you have a try-catch finally. There's a finally block. So go forth and